Hello friends, welcome to Engineering Funda family. In this video, I'll be going to explain you RPL protocol. This protocol is used for routing in internet. Specifically for IoT devices, RPL protocol is designed. Before I start with explanation, let me show you outlines of this video. So in this video, first of all, I'll be explaining you basics of RPL protocol. Then I'll explain you terminologies used in RPL protocol. After that, I'll explain you how control messages are forwarded in RPL protocol, and at last, I'll explain you how DODAG formation is done. So with the use of DODAG formation, we are providing routing of data. So in this video, I'll be covering all 4 points. Let us start this video with first agenda, that is basics of RPL protocol. When it comes to basics of RPL protocol, one should know this protocol is designed for routing. So RPL protocol is routing protocol, and that we use it for low power and lossy network. One should know what is the meaning of low power network. See, IoT devices are operated at lower power. So specially for IoT devices, RPL protocol is implemented for routing. Lossy network means what? Lossy network means here when you forward data at a time there will be higher packet drop rate. So in lossy network and with low power handling capabilities of devices, this protocol is implemented. See, in IoT you will be observing devices may have low power and lossy network. So RPL protocol is widely used in IoT networks. See, RPL is mainly used with IPv6, but it can also be implemented in IPv4. Right now in 2023, IPv4 and IPv6, both of IP protocols are there. This protocol is widely implemented with IPv6, but it can be also implemented with the use of IPv4. See, RPL is a basically distance vector routing protocol. If you want to understand distance vector routing protocol, then that I have explained in great detail in the video lecture series of computer network. See, here I'll be discussing about how this RPL protocol is implemented, right? To understand distance vector routing protocol, you just go through my video in lecture series of computer network. See, RPL protocol is based on distance oriented directed acyclic graph. In short, that is referred as DODAG. So how that graph is getting formed, that is what the case which I'm going to explain you in this video. Now I'm going to explain you terminologies which we use it in RPL protocol. To understand RPL protocol, first you'll have to understand RPL terminologies. Let me explain you those terminologies quickly. So first terminology is directed acyclic graph. In short, it is also referred as DAG. What is the meaning of directed acyclic graph? See, it is a graph which does not have any cycle. Means it does not have any closed loop. You can observe here by blue color we are having nodes, and these nodes are connected by links as per this black color edges, right? So in this graph we don't have any closed loop, or there is no cycle that one can say. So this is directed acyclic graph. Such graphs can be seen in spanning trees. If you want to understand spanning tree protocol, then that is also I have explained in my lecture series of computer network. You just go through it. Now next terminology is route. See, route is what? Route is a destination node of DAG. DAG means directed acyclic graph. So for this directed acyclic graph, if you observe, destination for all this node is this root node, right? So root is the node which is the destination node of DAG. It is not having any outgoing edge. So if you observe here with this root node, then it does not have any outgoing edge. See, next is up. Up means what? See, it is edge. By black color you can observe here edges are provided, which is providing connection in between nodes, right? So up means what? It is any edge that is directed towards the root. So here you see by black color, all the edges are directed towards the root. Means those edges are up edges that one can say. Down edge means what? It is any edge that is directed away from the root. So if you observe here by red color, this edge that is directed away from the root. If edges are going towards the root, then that is up edge, and as if edges are going away from the root, then that is down edge. Now let us see another terminology, that is destination oriented directed acyclic graph, means DODAG. See, here we are dealing with to form DODAG network. So first of all, you need to understand what is DAG, that I have explained, that is directed acyclic graph which does not have any enclosed loop. Here, see, this is a node which is spatial node, right? That is root node. So with the use of root node, we will be going to form DODAG graph. So DODAG is a spatial kind of DAG where each node wants to reach to single destination. So here, if you observe with this network, all the nodes are interested to reach to this single node, and that single node is what? It is root node. So this graph is DODAG graph, that one can say, right? See, objective function means what? Here, objective of this graph should be defined first, right? So objective function helps us to decide whether we are near to the root or away from it. So here, when you communicate in the network, at a time, how far you are there from the root, that you need to define. So objective of function is to stay nearer to this root node. So it is decided by programmer or designer, and it is something that we want to minimize. Means we want to minimize the distance with respect to root node. When you want to communicate with internet, at a time, this root node, that is playing essential role. All other nodes should be communicating to this root node with minimum delay, minimum latency. So here, objective function that explains you that we should be having minimum distance with respect to this node. That distance can be defined in terms of latency of transmission, in terms of physical distance of transmission, or number of hops. Number of hops means how many nodes are coming in between when node is communicating with this root node, right? Next is rank. See, rank is number of hops from the root. Like you see here, we are having root node. If you observe this node that is directly communicating with root, so this node is having rank 1. This node is also having rank 1, as there is only one hop to have a communication with this root. But when it comes to this node, then it takes 2 hop to reach to root. Means rank of this node is 2, right? So rank explains you how many hops that we need to have when you want to communicate with root node. Now let us have next terminology, that is RPL instance. See, RPL instance explains how many DODAGs are there. So when we have one or more DODAG, then each DODAG is an instance. So RPL instance explains how many DODAG graphs are there. So here I have shown you 2 graphs, right? Means here 2 DODAG network that is there as per the basic definitions which I have told you. Here also there is one root node. Here also we are having one root node, and all other nodes are interested to go towards root node. Means this is one DODAG network. This is second DODAG network. So for this particular case, we are having 2 RPL instances, that one can say, right? See, DODAG ID. DODAG ID that is been given to root node. First of all, remember this. DODAG ID that is given to root node. Other nodes cannot have DODAG ID. Now, why that ID is required? See, for a communication on internet, you will be using logical addressing. You may be using IPv4 or IPv6. Specifically, this RPL protocol that is designed for IPv6. So each DODAG will be having IPv6 ID, and IPv6 ID is having length of 128 bits. If you design this RPL protocol with the use of IPv4, then that DODAG ID that will be having size of 32 bits. But specifically RPL protocol that is designed for IPv6 network, right? So this DODAG ID that will be given to this root node, by which it will be communicating further on internet, right? So this ID is given to root only and it stays until the root doesn't change. Root doesn't change means it is possible that with respect to time, this network may change. So as if network is changing, then any node can be root node in that given network. So as if root node is getting changed along with the DODAG network, then ID will also change, right? See, DODAG version, each new shape of DODAG means new version. So whatever number of DODAG network is there, that is a version itself. And each version will be given with DODAG ID. In IPv6, it will be having size of 128 bits. As if we establish it with the use of IPv4, then it will be having size of 32 bits. But let me tell you one thing, right now in current world, 32 bits means you will be having 4 billion number of IP addresses. And with the use of IPv4, it is quite next to impossible. That's why in majority of cases, we will be implementing RPL protocol with the use of IPv6 ID only, right? The reason is with the use of 128 bits, you can have so many IDs, right? 2 to the power 128 number of IDs will be available. Now, when you talk about RPL goal, then goal is to provide best routing path using DODAG. As RPL protocol is there based on routing algorithm, our basic agenda is to provide best suitable routing path for given DODAG. The aim is to minimize objective function. Minimization of objective function means objective function explains how routing will happen. So routing should happen with shortest path, with minimum latency and with proper data transfer. And to make sure that here we are using RPL protocol, right? So our basic agenda is to provide best routing path with the use of RPL protocol, right? See, grounded means what? When DODAG reaches its goal means when objective function is implemented successfully. At that time, you can say DODAG have reached to its goal. At that time, that root node is known as grounded. Grounded means we are fixing that node as a root node, right? So once you design that DODAG network, there will be one root node, and as if that DODAG network is successfully implemented, then that root node will be grounded. So in figure by G, it is been shown over here, means it is grounded now. See, next is floating DODAG. Floating DODAG means what? When you design DODAG network, and as if DODAG network is not reaching to its goal, or as if DODAG network is not connected over internet, then that root node will be considered as floating node. So as if you are not reaching to your goal, then that root node will be floating node. Once it is reaching to its goal, it is considered as it is grounded now, right? See, parent and child node. So one should know, see, parent node is where the arrow is pointing towards, and the child node is where the arrow comes from. So here you can observe, see, this root node is a parent node for all these nodes, right? For this node, this is child node, right? And this is parent node. This root node is parent of this. So for this node is child of this root node. That is how things are there, right? So there can be multiple child nodes and multiple parent nodes in given network. So it is not like, see, root node is always parent, but see, this is child for this root and this is child for this node. That is how things are there. So there can be multiple child nodes as well as there can be multiple parent nodes in given graph. See, sub DODAG. It is a subtree of given DODAG. So as if you have subtree of network, like in this network, if this link is getting failed, then see, this will be subtree of given DODAG, right? Now, very interesting part that comes, that is storing nodes. See, storing nodes keeps the whole routing table. So here in this protocol, what we do is we transfer information to each nodes. So here the nodes which are having complete information, that is referred as storing node. At last you will get to know like what is the meaning of storing node. Right now just consider this. Here to form DODAG graph, all the nodes will be giving information to each other. Those information explains how routing is possible. So the nodes which are having all the information, those nodes are referred as storing node, right? So storing node keeps whole routing table. Storing node knows how to route packets from one node to another node, and route node is always storing node. So root node, that is always storing node. But other nodes are also having information about routing data or routing table, right? So those are storing node. If nodes are not having data related how routing will happen, then those are non-storing nodes. So non-storing nodes knows about their parent only. So parent means these nodes only knows about, they will have to send data to particular node, that is their parent node, right? So they don't have routing table. So that is how information is there. Now I'll be going to explain you RPL control messages. There are 5 RPL control messages by which DODAG network is getting formed. Let us have first RPL control message, that is DIS. See, this DIS message, that is specifically forwarded by new node to older node. Now what is the meaning of this? See, when you have existing DODAG network, in this network, if new node comes, then that new node may wants to join given DODAG network. So this new node will be forwarding this message to any of the node which is existing in this network, by which it is asking that whether DODAG network exists or not, right? So when no announcement is heard, and if a node wants to join DODAG, it will be sending control message. For that, it wants to know if DODAG network exists or not. The reason is, when you go somewhere, you don't know whether DODAG network exists or not. So newcomer will be sending this message first, right? That is DIS message, DODAG information solicitation message, right? See, next is DODAG information object, DIO. First of all, you need to understand this. See, this message can be forwarded by older node to new node in reply. This message can be forwarded by older node to new node in reply, as well as this message is used to form DODAG network. Like you see, here we are having so many nodes. Now there will be one special node, that will be root node. Now as if root node wants to form DODAG network, then what it will do? That root node will be forwarding DIO message in downward direction. In downward direction means the nodes which are rank number 1 nodes, right? Rank number 1 nodes means the nodes which are directly connected to root node. So it will be multicasting that in downward direction. Now those nodes also multicast in downward direction further, right? So DIO message, that is used to form DODAG network as well, where this message is getting multicasted in downward direction. Node in DODAG may multicast this message again, right? Which lets other nodes to know about it. Means now all the nodes will be having idea about, okay, root node have forwarded DIO message, right? And in that message, there will be some information like root node is grounded or not. Grounded means whether DODAG network is established or not, right? So terminologies that I have explained, as well as some other informations are there, like whether information is storing or non-storing. Storing means routing table is established or not, right? So routing table information is also there with that message, as well as it will be announcing that whether others are interested to join given network or not. So it will be announcing whether you are interested to join this network or not. It is saying like whether this network is existing or not, as well as it is saying like if you are interested, you can join over here, right? So this message can be forwarded by older node to new node, as well as at the beginning of formation, this message can also be used. I'll explain you how DODAG formation happens in this video itself, right? Now third message is DODAG advertisement object, DAO. See, this message is forwarded by new node to older node, as well as in given existing DODAG network also this message can be forwarded, right? So it is a request sent by child node to root node. as well as you can say this is a request forwarded by child node to their parent node even, right? Where this message request to allow child node to join given DODAG. So here by this message, new node can say older node that I just want to join this network, as well as in existing DODAG network, it can say, okay, I'm ready for a communication, so I'm available over here, right? So it is a request by new to old, or you can say from child to parent, right? Fourth is DODAG acknowledgement. So here you can observe in reply to DAO, now DAO acknowledgement that is been forwarded, in which now it is a response sent by root or parent to the child node. And this response says what? It says that whether you are allowed or not, means it will be saying yes or no. If it is saying yes, then new node is now allowed to join that network. If it is no, then new node is not allowed to join this network. And fifth message is CC. See this fifth message that says what? It says consistency check. So it is dealing with security and it is checking DODAG network, right? But for the formation of DODAG network, this message doesn't mean too much, right? But you should know CC is also a message, consistency check, by which security is also getting measured over here in RPL protocol, right? Now I'll be explaining you how we can have formation of DODAG network. DODAG formation is initiated by root node. The reason is root node is a special node in DODAG network. Root node holds DODAG ID. Other nodes cannot have DODAG ID. So one should know root node is a special node which is having DODAG ID, and beginning of formation of DODAG network that is initiated by root node, right? So root in DODAG is a special node. All nodes don't have the capabilities to be root node. A root node is programmed for it, right? So DODAG formation that is beginned by root node. Let us take one example. So here we are having 4 different nodes A, B, C, D, and we want to form DODAG graph. So here there are few basic steps that you need to understand. See, first of all, root node, that is node A in this, that will be forwarding DIO messages to all other nodes. So root node A will be multicasting DIOs to other nodes. By this message, this B, C and D will get to know what are the parameters which is there with the network. Let us consider distance is a parameter. So once this B, C and D is receiving DIOs, based on that B, C and D will get to know what is the distance with respect to A. Like B will get to know distance with respect to A is X. C will get to know distance with respect to A is Y. And D will get to know distance with respect to A is Z. Right. So once this BCD is receiving this DIO, BCD will be having idea about distance with respect to A. Now once this DIO is received successfully, BCD will be forwarding DAO to root node A. So here you see B, C and D is forwarding DAO to A, by which A will get to know DIO are forwarded to BCD successfully, and now A is also having idea about what is the distance which is there with respect to B, C and D, right? Now you see root node A is accepting DAOs and it is giving acknowledgement to BCD. In this acknowledgement, A is saying, okay, now I'm having data with respect to B, C and D, right? And to have exact idea about complete routing table, now same process that is getting initiated by other nodes. And see, this repetition will be happening with respect to nearest to the root. If I say in this network, this node B is nearest to A, then again this node B will be forwarding DIO to A, C and D, right? And then this ACD will forward DAOs to B, and then acknowledgement will be given. So what will happen in this complete network? What is the distance with respect to AB, AC, AD, as well as BC, BD, AD? That is how complete information will be there with all the nodes. And based on that complete information, now routing can be done. So here, by this control messages, all nodes are forwarding information to each other. In that information, they are saying that is how bandwidth is available, that is how distance is there, that is how latency is there. So based on parameter, based on goal, we will be forming that network. In that network, routing will be defined, right? So that is how DODAG formation is happening. I hope you have enjoyed this video. Still, if anything that you would like to share, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.